Welcome students. In this part, I am going to discuss oxides of nitrogen. As in our previous video, I have already discussed the oxides of group 15 elements. So here it is done for the oxide of nitrogen. As we know that nitrogen on combination with oxygen form oxides in the range of from +1 to +5 oxidation state. And we have already discussed the oxides of group 15 element. The group 15 element oxides, they form basically two type of oxides. One is trioxide and other one is pentoxide. So for group 15 elements, other than nitrogen, all the group 15 element shows a common oxidation state of oxide from +3 and +5. It is +3 oxidation state and +5, which is shown by which is a common oxidation state shown by other oxides of group 15, whereas nitrogen has a unique tendency to form the oxides in between the range from +1 to +5. Now, why it is so? We have already discussed the reason in our previous video. It is due to the p pi multiple bonding between nitrogen and the oxygen atom. Now, the most important oxides of nitrogen are NO, nitric oxide having oxidation state +2, and N2O, nitrous oxide having oxidation state +1. Similarly, N2O3, dinitrogen trioxide +3, NO2, nitrogen dioxide +4, N2O4, dinitrogen tetroxide +4, N2O5, dinitrogen pentoxide +5 oxidation state. So here we will first discuss nitrous oxide N2O. Oxidation state for nitrous oxide N2O is +1. Here oxidation state of nitrogen is +1. This is also known as laughing gas. Now the preparation of this laughing gas or the nitrous oxide, ammonium nitrate heated and it gives N2O, which is nitrous oxide, and water. On heating, ammonium nitrate, nitrous oxide and water are produced, and we know that, and this nitrous oxide, it is a colorless unreactive gas in nature. It is a gas which is colorless and unreactive. Similarly, it is also known as laughing gas, we know that, and it causes hysterical laughter when inhaled in even very minute quantities. And also it is this gas, it is a neutral in nature as well. Also, nitrous oxide supports the combustion. It supports combustion, acting as a source of oxygen. Why it is so? Since it decomposes into nitrogen and oxygen at 873 Kelvin. When it is heated, when nitrous oxide gets heated, it gets decomposes at 873 Kelvin and produces nitrogen and oxygen. So it acts as the source of oxygen as well in the support of combustion. So the reaction is nitrous oxide. On reaction, on heating up to 873 Kelvin, it gives N2 plus O2. Come to the Lewis dot resonance structure of N2O. How the atoms are arranged, how the electrons in the atoms are arranged. So let's see. We know that N2O contains two nitrogen atom and one oxygen atom. In this molecule, two nitrogen atom are there and one oxygen atom is there. So the valency electron in nitrogen are 5, and for one nitrogen the valency electrons are 5. So for two nitrogen the valency electron will be 10, and for oxygen the valency electrons are 6. So the total valency electron of the molecule N2O, nitrous oxide, it will be 10 electron for two nitrogen and 6 electron of one oxygen. It is 10 plus 6, it is 16 electron. So as we get the 16 electron, which is a even electron system, so we can say that this nitrous oxide is a even electron species which has even number of electron in its molecule. Now as we draw the structure of nitrous oxide, as I have already told you, this nitrous oxide is neutral in nature. As I told the property of nitrous oxide, it is neutral in nature. So the structure will have no charge. Now here nitrogen, the valency electron of one nitrogen is 5. So the nitrogen is combined like this, and here it is for other nitrogen also the valency electrons are 5. And the valency electron of oxygen are 6, we know that. So in Lewis dot structure, first of all, that atom will complete its octet with which require very less number of electron. जिस एटम को बहुत कम नंबर ऑफ इलेक्ट्रॉन की रिक्वायरमेंट है अपने ऑक्टेट को कंप्लीट करने के लिए, पहले वो अपना ऑक्टेट कंप्लीट करता है. सो द हेयर that atom is oxygen, which require only 2 electron to complete its octet. So 2 electrons of oxygen will combine with 2 electron of nitrogen. Here in this we know that nitrogen has 5 electron, so 2 electrons of nitrogen will combine with 2 electron of oxygen here, and they will form a double bond. Now the remaining electron in this central nitrogen are 3 now, because 2 are already used to form a double bond with oxygen. Now it has only 3 electrons. Now what will happen, this nitrogen will form a single bond with 1 electron of this side nitrogen, and they will form a single bond by sharing 1 electron from each. They formed a single bond, but 1 electron is remaining in the central atom. In this central nitrogen atom, 1 electron is again remaining, and what will happen, this nitrogen will share or will donate its electron to that side nitrogen, and they will form a bond again. So this bond will be a covalent bond, which is formed by the sharing of both the electrons from both the nitrogen, and this bond will be a coordinate bond, which is formed by the donation of electron from the central nitrogen. So as the situation is like this, so nitrogen, this central nitrogen will get positive charge because it is donating the electron to this nitrogen, and this side nitrogen will get negative charge because it is accepting the electron from this. So from here the molecule becomes neutral. One negative charge, one positive charge, it will be a neutral molecule. Now come to the resonating structure. Again, resonating structure can be possible. In this oxygen, here what will happen, the 6 oxygen will remain as the 6 electron pair, or all the 6 electron of oxygen will remain as it is, and nitrogen will share its 2 electron or will coordinates at 2 electron to the oxygen atom, and they will form a single bond here. Now the remaining 3 electrons of this central atom, they will combine and they will form a triple bond this side atom with the side atom. So here what is happening, as oxygen is gaining the electron, so it is become negative, and nitrogen is donating its electrons, so it will become positive. So again N2O molecule will be a neutral molecule, and this is the structure for this. And we know that it is a linear molecule, and in which bond length between nitrogen and nitrogen bond, it is 113 picometer, and the length between nitrogen and oxygen, it is 119 picometer. Come to the next type of oxide, that is nitric oxide, in which the oxidation state of nitrogen is +2. So come to the preparation first. Preparation, it is prepared by catalytic oxidation of ammonia at 1100 Kelvin in the presence of platinum catalyst. So it is the reaction ammonia on oxidation at 1100 Kelvin in the presence of platinum gives NO, nitric oxide plus water. Second, the reaction of HNO3 on copper. As copper combines with HNO3, it forms copper nitrate plus NO plus water will be formed. And the property of nitric acid is it is a neutral oxide. It is again a neutral oxide. Now it is a colorless gas as well, and NO has odd number of electron. The valency electron of NO are odd number. As we have discussed for nitrous oxide, the number of valency electron for in case of nitrous oxide it is even, and but in case of NO the valency electron for NO molecule are odd. And due to its odd number of electron, NO, it is paramagnetic in the gaseous state. As I told you, it is a colorless gas. So in gaseous state, this NO is paramagnetic due to the odd number of electron, due to free electrons. And In liquid and solid state it is diamagnetic. And why? Because it form a loose dimer in such a way that magnetic effects of two unpaired electron get cancelled, and they will form a dimer. It will form a dimer here. And we will discuss the Lewis dot structure of NO. And first of all, in gaseous state, NO is paramagnetic due to odd electron system, but as it gets dimerizes, अगर उसका एक और मॉलिक्यूल आएगा और वो दोनों आके एक डाइमर फॉर्म करेंगे, तो देन the dimer can only be formed in liquid and the solid state, and at that condition it is a diamagnetic. Why? Because now as forming dimer it will gain and it will become a even number species now, so it will be a diamagnetic. But in case of gaseous state it is paramagnetic. So let's discuss the Lewis dot structure of NO. As we noted, NO, it contains one nitrogen atom, and valency electron in nitrogen are 5, and one oxygen atom, valency of oxygen atom, valency electron in oxygen atom are 6. So the total valency electron in NO molecule will be 5 of nitrogen and 6 of oxygen. It comes to be 11, which is a odd number, so it is a odd electron species. Now let's see the resonating structure for it. Resonating structure is, we know that we have only nitrogen and oxygen. So what will happen first, as nitrogen has 5 valency electron, so 2 electron of nitrogen and 2 electron of oxygen will combine and they will form a double bond here. And you can see here 1 electron on nitrogen is in a free state. This is a free electron. Due to this it is due to this it behaves as paramagnetic in gaseous state, and also due to this free electron it is unstable as well. Now on drawing the resonating structure, again the resonating structure can be formed like, as the nitrogen has 4 electron, and in this case as oxygen will donate one of its electron pair to nitrogen, as oxygen will donate one of its electron pair to nitrogen, and here one bond will be a coordinate bond, and here the next bond of one electron of nitrogen which is in free state, it combines with other electron of oxygen, so they will form a shared bond which is a covalent bond. So this molecule is again a neutral molecule because oxygen is donating electron and nitrogen is gaining, so positive and negative, again a neutral molecule. Also this can also be explained as, if nitrogen will donate its 2 electron here, so the coordinate bond is due to the donation of nitrogen, and here it is the covalent bond due to the sharing of 1 electron of nitrogen and 1 of oxygen. So here the positive charge will be on nitrogen because it is donating to oxygen, and negative charge is on oxygen because it is gaining from nitrogen. So overall molecule will be a neutral molecule. Now let's see the structure of this. The bond length between N and O, it is 115 picometer. And if in gaseous or the liquid state, when two NO molecule combines together, so they will form a dimer of NO, N2O2. And in N2O2 molecule, the bond length between N and O, nitrogen of one NO, nitrogen from one NO molecule and oxygen from other NO molecule, the bond length between those two will be 238 picometer, whereas the NO of the same molecule, the bond length between N and O is 115 picometer. Now let's see some properties of nitric oxide as well. Nitric oxide reacts with oxygen to give brown fumes of nitrogen dioxide. And the reaction for that, NO combines with oxygen, it forms nitrogen dioxide NO2, which is of brown color, and it fumes like it is a gas which fumes in brown color. And NO forms complex with transition metals as well. NO has a tendency to form complex with transition metals, D block elements, like it can combine with iron. Example is, it can combine with Fe2 positive and form the complex, and the complex formed is this FeH2O5NO and whole 2 positive, and this complex, it is responsible for brown ring taste for nitrates as well. This is used, or it is useful for the brown ring test for nitrates. And one property is also there, the nitric oxide NO, it is thermodynamically unstable. It means when you provide some heat to nitric oxide, it will get uh, break, or it is unstable. So what will happen, it decomposes at higher temperature. So the reaction is NO, it is a gas, and at very high temperature around 1373 to 1473, it can decomposes and can get the products N2 and O2. Now come to the next third type of the oxide of nitrogen, that is dinitrogen trioxide N2O3. Oxidation state for N2O3 will be +3. Nitrogen oxidation state of nitrogen will be +3. And the preparation for dinitrogen trioxide is by cooling equimolar quantities of NO, nitric oxide, and NO2, nitrogen dioxide. So NO, on combining with NO2 at around 253 Kelvin, we can easily form N2O3 from here. Again, the reaction of NO with N2O4, reacting NO with N2O4, we can also form, on combining NO and N2O4 at 250 Kelvin, we can also form N2O3 from here. Properties, it is blue solid, it is blue colored solid, and it is acidic in nature as well. And its acidic nature can be seen by the reaction as N2O3 on reaction with water, it produces nitrous acid HNO2. Since on reaction with water it forms nitrous acid HNO2, so we can say that as it is forming acid, so it is a acidic in nature. Since we know that, and we can say that dinitrogen trioxide N2O3 is an anhydride of nitrous acid as well. And it exists in pure form only in the solid state at very low temperature. N2O3 can exist in solid state, and at its solid state it is in its pure form, or the temperature at which it is present in its pure form, it is very low temperature, and above its melting point is around 173, it dissociates into NO and NO2. अपने सॉलिड स्टेट में तो स्टेबल होते हैं अगर हम इसे लो टेम्परेचर पे रखें, लेकिन अपने मेल्टिंग स्टेट, बिकॉज वी आर टॉकिंग अबाउट सॉलिड स्टेट, सो अगर मेल्टिंग पॉइंट की बात करते हैं, तो अगर ये अगर अपने मेल्टिंग पॉइंट टेम्परेचर से हाई टेम्परेचर से प्रोवाइड किया जाए, अराउंड 173 से हाई अगर टेम्परेचर प्रोवाइड करेंगे, सो ये डिकम्पोज हो जाता है इंटू NO एंड NO2. And the reaction is this blue color of N2O3 above 173 Kelvin, it can give NO, which is a colorless gas, and NO2, which is of brown color. Now let's see the Lewis dot structure of N2O3. As there are two nitrogen atom and 3 oxygen atoms, so they can combine in that manner, in this manner also. Here the one nitrogen can share its 2 electron with oxygen and form a double bond, and here it is one nitrogen sharing 1 electron with other nitrogen and forming a single bond in between them. But this nitrogen here, now the nitrogen, as we know that the valency of nitrogen is 5, and now the nitrogen has, now as it form bond with 3 electron, now it has only 2 electrons, so it will donates or coordinates its 2 electron to the oxygen and form a single bond here. So the nitrogen will get positive and oxygen will get negative again. And this nitrogen here, it is sharing its 2 electron to the other oxygen and forming a double bond here. So here these are the 5 electrons of nitrogen, and they are forming the total number of they are completing its octet up to 8 here. 1 2 3 4 5 6 7, and this is 8. So this is the resonating structure for this. When this here at this time this oxygen is gaining or coordinating with the nitrogen, and for other resonating structure, if this oxygen will contain or with coordinate with the bond of nitrogen, so it will be get negative, nitrogen will get positive here. So this will be the resonating structure of N2O3. And now let's see, it will be a planar molecule in which nitrogen oxygen bond length is 121 picometer, nitrogen bond length is 186 picometer, and this nitrogen oxygen bond, this single nitrogen oxygen bond length will be 114 picometer, angle is 105, and the angle between nitrogen which is having two oxygen at bond angle is 130, and the bond angle between this oxygen and the nitrogen, the bond angle is 170. Come to the fourth type of oxide, nitrogen dioxide, NO2. Oxidation state of nitrogen is in NO2 is +4. Preparation. Nitrogen dioxide can be prepared by dried lead nitrate. On heating dried lead nitrate, it produces nitrogen dioxide NO2, oxygen and lead oxide. And also the properties of dinitrogen, it is also an odd electron molecule. It is again an odd electron molecule. It has odd number of electron in its valency shell or in its gaseous phase. It exists in equilibrium with N2O4 dinitrogen tetroxide, and it exists as dimer with dinitrogen tetroxide. On heating dinitrogen tetroxide, we can get NO2, or cooling NO2, we can get dinitrogen tetroxide. So let's here see the Lewis dot structure of N2NO2 nitrogen dioxide. Here we can see here that this NO2 contains one nitrogen atom and two oxygen atom. So the total number of valency electron for the molecule will be 5 plus 2 oxygen atom means 2 into 6, it is 12. So total number of electron comes to be 17 valency electron. So as it gets 17 valency electron, you can see from here also, as it gets 17 electrons, so it is a odd electron species, and as it is a odd electron species, so we have a free electron in any one of the atom. और अगर इसके पास किसी भी एक एटम के पास फ्री इलेक्ट्रॉन है तो वो एटम अपनी स्टेबल स्टेट में आना चाहेगा. अगर वो इलेक्ट्रॉन अपनी स्टेबल स्टेट में आ रहा है तो वो कंबाइन होगा दूसरे मॉलिक्यूल से एंड इट विल फॉर्म अ डाइमर अगेन. तो गैशियस स्टेट में ये मॉलिक्यूल भी अनस्टेबल है बिकॉज इसमें एक फ्री इलेक्ट्रॉन प्रेजेंट है, और वो जो फ्री इलेक्ट्रॉन है, दैट फ्री इलेक्ट्रॉन इज ड्यू टू द odd electron species, is due to the odd number of valency electron of NO2. And the structure of NO2 is angular, in which the bond angle between N and O, it is 134 degree, and the bond length is 120 picometer. Now let's see the structure of dinitrogen tetroxide, which is a dimer of nitrogen dioxide. So dinitrogen tetroxide, two nitrogen atoms will combine in with a single bond, and the oxygen nitrogen combines with a double bond with one oxygen, and here it will coordinate its bond to that oxygen. Here it is also coordinating its bond to that oxygen, so it will be a neutral molecule again. It will gain positive, this will gain negative. If this it is forming coordinate bond with this oxygen, so this nitrogen will get positive and this will get negative. Again the resonating structure. So again here this again at this time this electron is coordinating or gaining electron from nitrogen, it will get negative, and this nitrogen will again be positive. This is positive, and here at this time this electron is gaining negative, so it is a negative charge. And the bond length, it is a planar molecule, and the bond length is between nitrogen and nitrogen 175 picometer. The bond angle is 135 degree, and the bond length between this nitrogen and oxygen is 121 picometer. Now come to the question, why does NO2 dimerizes? The question is, why does NO2 dimerizes or form dimer which is of N2O4? So NO2 contains, as we have already discussed, NO2 contains odd number of valency electron, that is total number of electrons are 17, 5 electron from nitrogen and 6 are from oxygen. So 2 into 6, it will get 12. So total number of electrons are 17. Due to this, it is unstable and get dimerizes to N2O5 क्योंकि it has free electrons in nitrogen. ऑड इलेक्ट्रॉन होने की वजह से नाइट्रोजन के ऊपर फ्री इलेक्ट्रॉन आया, और वो फ्री इलेक्ट्रॉन फ्री स्टेट में ज़्यादा टाइम तक स्टेबल नहीं होगा, तो वो डाइमर फॉर्म कर लेगा दूसरे NO2 मॉलिक्यूल के साथ, और जो डाइमर बनेगा दैट इज N2O4. and the dimer N2O4 now have even number of valency electron, और so as the dimer have even number of valency electron, so जो अब जो dimer होगा that is a stable molecule. So this is about NO2. Now come to the last oxide of nitrogen, dinitrogen pentoxide N2O5. Oxidation state is +5, and preparation on dehydrating nitric acid with phosphorus pentoxide, we can easily get dinitrogen pentoxide N2O5 plus HPO3. And this N2O5 exists as colorless solid, and as temperature rises the color changes to yellow. It is colorless below its melting point, and as the temperature rises the color changes to yellow for N2O5. And you can see in the reaction also here, this N2O5 initially it is colorless, and as the temperature increases it get decomposes to NO2 and O2, and this NO2 is of yellow color as the temperature increases. Now let's see the Lewis dot structure, resonance structure of N2O5, and this will be the Lewis dot structure of N2O5, in which the nitrogen atom is forming a bridge with one oxygen atom here, and the bonds are similar like N2O4, but the one oxygen is extra which is forming a bridge with these two nitrogen. So this will be the resonating structure, and you can see here it is again a planar molecule in which the bond length between this middle oxygen and nitrogen is 151 picometer, and the angle is between two nitrogen and this oxygen is 112, and the bond length between this nitrogen and this oxygen is 119 picometer, and the angle is 134. So that's all for today. Now I have some questions for you as a home assignment, so do these questions and we will meet in our next video with our next topics. So here it is. Question number first is, which oxide of nitrogen is prepared by heating lead nitrate? Give reaction. Second, give an example of compounds in which the oxidation states of nitrogen is +3, 0, -3, +4. Complete the following reaction. You have to complete these reactions. And the last one is, write the formula of the compound formed during ring test of nitrate radical. So that's all for today. We will meet in our next video with our next topic. So keep watching. Thank you.